And this is the video tutorial on how method to model this part. It's the S60-137 axle. Okay, so we have an isometric view giving us our basic dimensions. For this, we're going to need the major diameter for a 632 UNC 2A thread so that you don't have to look it up. I've included it in the notes there. This is what's called a flag note when you have a symbol. It could be a triangle, circle, or square, or like this, it's called a circle on square. And it correlates to this dimension that it's next to, and it's flagged. So it's a specific note instead of a general note. Different companies put their notes in a different format, different places. They may use more than one symbol for the meaning of the note. I'm used to doing aircraft where you have the notes in the lower left corner and you start with one and go higher in reverse order. And the reason is you do your revisions, you can just keep adding the notes above it and not have to change the numbering scheme. So anyway, so this is a revolved part. We have a thread on both sides. I'm going to show you two different methods on how to create the thread. What we're seeing right now is a modeled thread, so it actually physically looks like a thread. But there's a simplified version that has some advantages, and it's called a cosmetic thread. So we're going to use two different tools for that. All right, let's start with modeling our shape. Now, to use the thread command where you see the threads modeled, you have to actually model a boss feature before you apply the thread that's at the major diameter you need. So that's why we need this 138. The other option is going to be used called the stud command. We will use it, but it doesn't actually require geometry to be there. And it'll create a cosmetic stud on a placed location similar to a hole, but in inverse. Okay, so here we go. Let's go to SolidWorks. We're going to make a new file. Okay, so we're making a new model file, and we're going to sketch so that our primary view of it revolved is going to appear in the front plane. And we're going to start off with a center line. Let's anchor that center line to origin, draw it to the left. Let's hit escape to deselect that tool. We're going to select the line we just made, and we're going to make it infinite length. I found this is easier for students. Let's just make it infinitely long. Not the cleanest on large assemblies, but it'll be easier for you to select. Okay. Now we're going to start drawing our shape. So start at origin, come up. We got one edge of the boss. We're going to come up. This is the largest diameter. We're going to go down, across, down to the center line, and back to our origin. So we have our rough shape sketched very quickly. Okay. Now let's set up some relationships. We know this line and this line are the same length according to our drawing. So both of those are 20 thousandths. I'm sorry, 200 thousandths. So let's go ahead and set up a relationship that this line, hold the shift key after you select the first item, and then you can select the two items and make an equal relationship. So no matter what dimensions we apply, those will be equal in length. Okay, they're also the same diameter. So let's highlight them again. Highlight the left one, highlight the right one, and we're going to make those collinear. So they're always going to be the same diameter. Okay, we're done with relationships on this. We're now going to use dimensions. Okay, and here's how we dimension a diameter. We go to the small diameter here. You pick on the line, not the corner, not the middle, but the line itself. And then we're going to pick down on the center line. You have to have a center line to do this. And right now it's giving you a radius. But if I drag my cursor down below the center line, it gives you the dimension in diameters. Your drawing's in diameters. That's what you want to display on your drawing. So we're going to click here, and it's 0.138 is the major diameter of a number 6 screw. Okay, so we've got our diameter set. These two turn black because their diameter is locked in. The vertical line turns black because it's locked into origin. Remember, you need to anchor your model somewhere on origin. Okay, now let's do our other diameter. We're going to our drawing and let's look what our size is. So we got a 189 to 187. So we need the number that's halfway between there. Okay, so if we were to get our calculator and figure out the average of the tolerance, we first take the first number, 0.189, subtract the second number, 0.187, which gives us a 0.02 difference. You divide that by 2, and it's 1,000th. If we add that number to the low number, 0.187, we get the middle. Okay, so our average of the tolerance we want to model to is 188. I'm going to copy that number on the calculator. We're going to go back to SolidWorks. We're going to do a dimension from the diameter we want, and I guess my center line was already highlighted, so it gave me that. But if it wasn't highlighted, you got to draw your cursor down below the center line in order to get a diameter. And then we should be able to hit Control V on our keyboard to copy from the calculator to our dialog box, which it did, 188, and accept that. And then we got to remember to come over here and go to 3 place decimals. Okay, and then we're going to do a limit dimension, and we're going to put in our tolerance, which is 0.001 or 1,000th, and 0.001 on the other, and we get our display the same way. Now if you want to auto center your dimensions, you can use this icon here, and it'll center the dimension between the dimension line. Okay, we're going to accept that. Now this top line is now turned black because the diameter is defined. What is not defined? The length of this black line, the length of this black line is not defined. Okay, so we're going to go and define those. Our drawing says this one is 200 thousandths, so 0.2. Now I got a little small nub because, I just arbitrarily drew mine. That'll correct itself, but you notice these two lines are now the same length, okay, and they've now turned black here and here. The left is blue and the left here is blue because we haven't defined the length of this line here. So we're going to come up, we're going to hit accept, and then we're going to pick on this line again. Don't pick on the center and don't pick on the edge. You got to be deliberate with where you're putting your mouse. Otherwise it's going to pick up a relationship that you don't want. So we're going to pick on the line itself. Pick on the line itself, drag your dimension up, and that one is a 1/2 inch. Alright, so there's our overall shape. And I do need to modify some of my tolerances. I didn't pay attention to that. So let's look at our drawing and make sure all our tolerances are correct. So I did this one. The 187 and 189. Let's check out this. This is supposed to be 138, which it is, but I needed to go to 3 place decimals. Okay. And then, if you want to, you can also center that, although it puts it right on your center line. All right, the 200 here, let's see what tolerance we're at on that on our drawing. It's at 2 place, and so is the 1/2 inch. So they're already at the right tolerance. Okay, so we have everything we need to revolve this shape, which is in effect a 1/2 cross section of your part, and we're going to spin it around this center line. So let's go to features, and we're going to revolve a base, and we're going to go to an isometric view, and it's going to preview it. It should look something like this. And if everything went well, you should be able to hit accept, and there is your base shape. Okay, the next step is to put the thread on the ends. I'm going to show you two different methods, so the two ends are going to look different. I don't care what you do for your assignment. I just want you to know the difference. And when you submit it, you could have, I'd like them both to look the same. Okay, so if you choose to go modeled, that's fine. Just make sure both ends are modeled. I do want you to practice using both. Okay, so we're going to go to Hole Wizard. Both of the thread functions are under Hole Wizard, even though this is not a hole. They should rename this Thread Wizard, but it used to only do holes. Okay, so we're going to pick on this one that says thread. This is what the older version, it's the way to model the thread so you actually see one there. Okay, and it's warning you, the thread tool type and size profiles are nominal thread profiles only. Do not use them for production quality threads. To create production quality threads, modify the nominal profiles to meet your design. So if the machinist is machining this, it's actually easier for them to just have a cylinder because they use their software to make the thread properly. You're working with specifying those threads. So unless you have an illustrative reason to show physical threads, for drafting purposes, I would suggest you go with cosmetic. Okay, so we got our thread location, and we're going to put it on the boss here, and it has a default thread size that pops up and a length. And it also defaults to a blind condition where you put a typed in spacing. Let's switch that to selection. You can choose number of revolutions, but I'm going to go up to selection. I'm going to pick the shoulder. Okay, and that's where it's going to stop the thread. Now, let's look at this. It's gouging into the part, and it doesn't start at the very end. The reason is it's going the number of threads till you have a fully formed thread on either end. So what we need to do is offset these ends. So in our two boxes, since we picked these edges, you can offset. So our first edge is over on the right. We're going to pick on the offset command, and you notice it moved in by default by whatever value is here. It's actually the wrong direction. That's okay. And we are going to offset in the opposite direction. So we're going to put in our thread that we're going to be doing is a 632 according to our drawing. So that means it's a number 6 screw with 32 threads per inch. So one thread spacing is 1/32 of an inch. We can type in 1 divided by 32 into our box. Okay. And now it updates the thread. It looks a little bit coarser. And then we're going to reverse the direction of the offset with this arrow here. And that way it starts off the part and cuts into it. Now, our current selected thread is not the 32, so we got a finer thread than what we're going to have in our end result. But this is the offset for the first selection. For the end condition is in this other box. I accidentally minimized it. So we're going to pick the offset button on that, and right now it's offsetting again for 40 thousandths into our shoulder. We don't want that. We're going to put 1 divided by 32 because it's 32 threads per inch, and then we're going to reverse the direction of the offset. Now you notice it's a little bit short because right now we have an 80, so it's 80 threads per inch is what the thread's set for. I probably should have set our thread size first, but I'm going in order, working down on the menu. So we're going to go to this size. Instead of having 80 or 080, we're going to pick what our drawing says, 632. And it should update to where our last thread terminates before the shoulder and it starts after the shoulder. Okay, and we're going to hit OK. So there's our thread, and it cuts in. Looks like a thread. Okay, now on the opposite side, let's use the other method. We're going to use the Underhole Wizard. We're going to go to Stud Wizard, and it's asking what edge are we going to put a stud on, and the first icon creates a stud on a cylindrical body that's already there. This other option is it creates it on a surface. So if you laid out a series of hole patterns, you could use that to create studs there instead. So you have to create a sketch ahead of time with where your points are with dimensions, and then you just select on those points, and it'll create the whole stud feature for you. Okay. We're using this first method here. We're going to pick on the edge here, and it's going to automatically put a chamfer on the end, and it's picking up 632. That's probably because I've already selected that. You can do machine threads. There's a bunch of different standards you can use. And then this one, it says blind. Okay, so it's going 20 thousandths, but you could also go to up to next, and it'll just go up to the next feature, which in this case, it's the same value, so you don't see anything changing. But that's one way. If you build that in, if I changed the length of this, it would automatically update, as opposed to if you put in a punched in value, you have to change that as well. This also allows you to add the thread class, which the other method didn't. So this helps you on the drafting side. With UNC and UNF threads, it's 1A, 2A, or 3A for an external thread, and the letter B will be there for internal threads. 2A is your common tolerance, 1A is very loose, and 3A would be a high performance tolerance. Okay, we're going to hit OK. And it puts a cosmetic circle hidden line like you would on a drawing, and then your outside is your solid line, and you notice it adds a lead-in chamfer. That's sized to the thread you're doing. All right, so that's done, and but you don't see any cosmetic threads other than the circle. Now, one thing you can do, if you elect to, you can go up to File Properties. I'm sorry, you go up to Options, and we go to Document Properties and select on Detailing. You can choose the shade Cosmetic Threads. You hit OK, and it's going to put a shaded pattern there to denote that there's a thread there. It doesn't create any geometry. It's just from a distance it looks like there's a thread. One advantage of this is it uses a lot less processing power. If you think about the math that's involved with making these helixes, if you have an assembly that has lots of threaded features in it, thousands of fasteners and stuff, it can bog down your large assembly. So you generally try to avoid doing these kinds of threads unless you need them for illustration purposes, and go with the machine thread studs. Okay, it saves lots of memory, file size, that kind of thing. All right, that concludes the tutorial for this particular part, the S60-137. Make sure that you've applied your material. Make sure that all your sketches are fully constrained so they don't have a little negative symbol next to them. Set your material for what the drawing has. I'll let you do that. Have a little shorter tutorial here, but don't forget to go to your properties and fill out this and set your material as, I believe in this case it's brass. All right, thanks a lot, and I'll catch you on the next one.